All right, good morning, everyone. Um, my name is Oluyeye Anthony, and the topic of my presentation this morning is steps in building an object detection model. Is under artificial intelligence. So I'll be going right into it. So the outline for my presentation, we have the introduction, the data acquisition, annotation, feature extraction, the training proper, the evaluation, and the conclusion. So going straight into the introduction, we need to understand what object detection is. So object detection is an aspect of artificial intelligence where the computer vision is of optimal use. Is one of the computer vision technique for locating a particular object in streams of videos or in an image. So it's just a way of for making computers to mimic the humans, such that the way the human eyes work, such that a computer is able to know that, okay, when it sees a cap, it can say, okay, this is a cap. When it sees a dog, it can say this is a dog. When it sees a cat, it can say, okay, this is a cat. It's just like making computer recognize an object. And this is mostly used, when you watch all these movies and you see all this facial recognition system, you see a particular box being drawn around the face of somebody, to show that they are actually, the system actually recognize the person. So in this image that is showing on the screen, we can see an image on the left side whereby there are cars. But after going through an object detection algorithm, we can see that the computer or the system is able to detect that there are vehicles in the image. So this is not only not only particular to images, it can also be used for video streams too. So you can also put an object detection algorithm in video, such that whenever the system sees an image that it has been trained with, it is able to detect or recognize it at a point in time. So we are going to dive into the steps involved in training an object detection system. So the first step is actually data acquisition, or you call it data collection. So we have different ways we can acquire data. We can acquire data through public data, scraping the web, or taking photographs. So the public data is such that there are public repositories where you can get data from. There are people that have already done the collection of data for you. All you just have to do is just go to their repository, pick up the data that you need, and you just use it for your training and do proper referencing for them. We have the COCO data set. That one is done. Is collected by Google. It is called the common object in context. We have the ImageNet. We have Kaggle. Those are public repositories where you can get data from. We have the second one is scraping the web. You can actually go to the internet, search for pictures of what data you need. Let's take, for instance, you are trying to train your computer, or you are trying to train a system to recognize Cristiano Ronaldo, for instance, all you have to do is just collect images whereby we have Cristiano Ronaldo in it, and just make sure you have a lot of them, because without the system getting familiar with the actual face, it will be difficult for the system to detect or recognize the objects you are trying to detect. And the last one is actually taking photograph. So there are images whereby maybe you might have little images on the internet about what you are trying to train the system to detect. Maybe you are trying to train the system to detect some personal things, maybe a face of somebody that is not popular. You might have to take a lot of photographs about that particular object we are trying to train. So you can also create data for the public use as well. So you can also take photographs of people, photographs of objects, and just make it to be usable for others as well. So you can see these are images that has been collected by people. We have the ImageNet, we have the Caltech, we have the Corel, we have the Coco, and all that. You can see how people have actually taken pictures of objects they are trying to train. So the next step is annotation. So after we have collected our images, after we have collected the data that we are going to be using, so we have the image annotation. This is just a process of labeling or classifying an image using some annotation tools or some other features. We have some algorithms or some tools we can use to annotate our image. Most of the time, annotation is also, we can call it labeling. You're actually labeling an image. We might have an image that consists of, maybe probably we are training our system to recognize a cat, for instance, and we have an image that consists of lots of things. We have lions inside the picture, we have cats, we have other things, and we want to train it to detect a dog. We have to label the part that has the dog there. So and that is what annotation is, actually labeling the images. Because let's say we are training the face of somebody, and we know that definitely the whole part of the body is not the face. So recognizing the person, we only determine that we label only the face of the person. And you can see one of the annotation tool that we have is called label IMG. It's called label IMG, and as you can see on the screen, this particular itel phone is being labeled for recognition. You want to train a system to recognize some phone. So we're actually training labeling it using an annotation tool called label IMG. So we have other labeling tools such as label box, label me, we have the CVAT and others. So this is one way we can label our image for training. So the next step on the line is feature extraction. So feature extraction, as the term implies, is actually extracting some form of features in the particular object we are trying to train. Like we are trying to convert some of these features, because definitely our computer cannot really deal with image. There's a way the computer sees image. So are trying to like convert some of these the image into a form of pixels so that we have some features about the image. Let me quickly rush into it. The next step is the training step, and it is also divided into 4 steps. So we have downloading a pre-trained model, configuring the training pipeline, training the model, and saving the models. So the pre-trained model, what do we mean by a pre-trained model? Maybe, for instance, we are trying to train a face mask system, a system that recognizes face masks on people's face. We can actually download a pre-trained model, a facial pre-trained model, to first of all help us in quickly recognizing faces. Then we can now build on that pre-trained model we can fine-tune the model and train on it to help us recognize the face mask on the faces. So we have configuring our training pipeline. The training pipeline is just like a file. We have the pipeline.config file for TensorFlow object detection API that helps us to know where some directories is supposed to be during the training process. So we have the training proper. So training the model is just that part where the training process is being initiated. So it can take a lot of time depending on how many data sets we are making use of, how many images we are trying to train. So, and the last one is saving the model. So after we have trained, the training might take so long period of time, but after the training has been done, we can now save the model for use. We can then put it into our computer or into a system for recognition purpose. So this is a training process going on the you only look once algorithm, and I don't know if you can look very closely. There's these are some of the logs that are coming out from the training. It also has the number of time that is left for the training to be done. So this is a training process that is going on. So the last step, which is the 5th step, is the evaluation step. So this is the step whereby you have to like look at how accurate it is that your model that you have trained, how accurate it is to recognize an object. So definitely this is a computer. It is not meant to like there is no 100% accuracy. Even though we might have 100% accuracy, but most of the time we have, probably if we have 80% accuracy, then we can say we have actually trained a very good model, and then we can have 90%. So there are some metrics that is used for evaluation. We have the precision, we have the recall, we have the intersection over union, we have area under curve, we have mean average precision, and some other metrics that is being used, and we have accuracy too. So it's actually, we can actually train a system that is going to recognize maybe a dog. At the end of the day, when a dog even passes through it might not even recognize, or when it even sees some other object passing through it can recognize it as a dog. So we need to like evaluate the model that we have trained. So I've come to the end of the presentation. So these are just the basic steps we need to train an object detection model. Thank you very much.
All right. Thank you. Thank you for that presentation. Our next presenter is Mr. Michael. I think he's having issues with his network. So you will need someone to help him share the slides. This who can help us do that. Hello. Mohammed, did you say something?
Okay, I hear me.
Mohammed, hello. Or you're really breaking.